All right, welcome everybody to week 16, day 2. I heard somebody talking. I guess he has muted himself now. All right, so yeah, anyways, the first big thing is the hash tables competence exam is up. I don't think it's too hard. It should be pretty easy if you know hash tables. So go ahead and take a crack at that whenever you want. It's due on Monday, start of class. Let's talk about the groups, I guess. So Huffman groups over here, go to Canvas, people, Huffman groups. There's a lot of people that are not in a group right now. So find a group. There's only 1, 2, 3, 4, 5, 5.5 groups made. So most people so far are not in a group for this. So if you need a group right now, talk on the Discord channel. If you're watching this video later, just go into the Help Center, say looking for group, LFG, and get yourself partnered up, because this assignment is annoying enough that you're going to want to work on it with somebody if possible. So you don't have to use my starter code. The binary writer I would say you should probably use. But you don't have to listen to me. You can kind of do it however you want, as long as your compression ratio works out the right way. The compression ratio is actually what you're going to be graded on. So if you use some other, like if you find Huffman code online, you're probably not going to get the same compression ratio, and your code's probably not going to grade. So I am aware that there are Huffman compression codes out there. Just be aware that if you use them, you're probably not going to pass the test. So there's a couple different ways of doing it, and all of them basically boil down to you sort all the characters by count, you take the 2 smallest characters off, make an intermediate node with a count of the sum of the kids, and push that back into the heap. And so you just constantly are popping the 2 smallest off, putting an intermediate node for them, pop 2 smallest off, put the intermediate node back on, 2 smallest off, intermediate node back on. You keep doing that until you got 1 node left. And that's Huffman coding. And then you just iterate across the tree, and every time you go left, that's a 0 bit. Every time you go right, that's a 1 bit. And when you get to a leaf, you write down the string that they correspond to. You dump that dictionary file to disk, and you use that to encode the file. So you have until next Wednesday to do this. I see binary reader H missing in the list. Is it just me, or do we have to create one? Yeah, you don't have to. You only have to write. You don't have to read. So you only have to compress the the files. You don't actually have to uncompress them. If you guys want to do that as extra credit, I'm fine with that. But this assignment is tough enough as it is without needing to add to it. So I use the compression ratio you get to see if you did it right, essentially. So. And the files that I'm going to be probably have you guys compress for some of the input tests won't match the ones in the input tester live, so you can't just hard code in C out 1.6, C out 1.4. Nah. I've had students do that before, and it's kind of annoying. They just try to hard code the answers in like that. Okay, so any questions about Huffman coding, implementing it conceptually? Everybody's super confident they can do it. Get a partner. It's 20 points. If you don't do this, it's going to tank your grade. So give it a crack. It's not. It is a fair bit of work, but it's doable with the skills you have now. You need to have 3 different data structures: the histogram, the tree, and the heap. And just you're going to be popping and inserting things like that. Is it the last assignment? No. It is not. But it's a 20-point partnered assignment, and the partnered points are worth more than the individual points. And so if you don't do this, it'll probably drop you a letter grade in the class. And so I take it very seriously and really start working now on it. Okay. Is there not supposed to be a Readme? Isn't there a Readme? Not, I can make one for you. Guess there's no readme. The main itself says what steps to do. I can put together readme for you. Here's a working histogram and hints. How to do heaps. And make a try. Yeah, so there's lots of sample code in the hints.cc that you're welcome to borrow if you don't want to write the whole thing yourself. Okay. So I've given you guys lots of sample code and hints inside of hints.cc. There's also a script, a shell script called binaryview.sh. If you try running it, it won't run, right? Because it's not set to be executable. So do you guys remember how to make a shell script executable? Chmod. Yep. Chmod, the user may execute binaryview.sh, and then you can binaryview.sh, say hamlet.encode, and that'll print out all the ones and zeros. So you can see if the ones and zeros you're getting out are the ones that you expect. Yep. Chmod Chami. Okay. So I've given you a shell script that uses XXD, yeah. It's a hex. It says hex dump, but it's actually going to print it in not hex. It's going to print it in binary, like that. So this will show you the ones and zeros inside of your file, and you can manually make like a test file. You know, BBAAAC. And then when you encode it, you can look at the dictionary you've made and look at the bits that are coming out in the encoded file and just make sure that everything's working right. But seriously, like start now on it. Okay, start now on it. So if there's no questions, I'm not going to lecture on it anymore. So now's your chance. Okay, there is silence on Discord. So, good luck. So, we are going to continue our discussion of Java today. Your final assignment is going to be in Java. You're not going to get that assignment until, you know, the Huffman coding, is done. Let's see if I have some sample code in here. Yeah. That's in there. Okay, I've pushed out to all of your directories a folder called Java. This has some sample source code in it that will kind of get you started. It's got a complete sort of description of the Java language, and I'll just pull up the PowerPoint presentation. We can take it from there. But that Java directory that I pushed out to you, it's on a homework assignment. It's got the complete everything you need to know about Java. And if you think, oh, that's weird, we're learning a whole new programming language in the last 2 weeks of school, it's like, yeah. And it's actually quite doable. The Java language really is C+++++, right? Wait, no, that's C#. C++++ forms the sharp sign, right? But it really is just a derivative of C++ that always does bounds checking and always has safety guarantees so that you can't get the hacks. That's what it's really good at. It was supposed to save Sun Microsystems because everybody would start writing Java programs, and then Sun would be able to run programs. They'd have programs and games for it because everybody was writing for Windows, right, and Mac. So Sun Microsystems was dying, and so they invented Java, and it became very popular. They actually succeeded at making a language that outlived the company. But yeah, nowadays there's not actually too many programs actually written, like desktop apps, I guess. Maybe there's some. It's fairly uncommon to see a program written in Java these days. But the idea was everybody writes to Java, and Java, because a Java program runs on top of this Java virtual machine, it'll run the same way on every platform. This is the idea of Java. You write a program once, and then it'll just run on a Mac, it'll run on a PC, it'll run on a Sun OS box, the same way. You don't have to port it. Porting applications between Mac OS and Windows and Linux is annoying. And so with Java, you only have to write your program one time, and it'll run exactly the same way in theory. It'll run exactly the same way on all the major platforms, including Sun, because they wanted people to actually use Sun, and have programs written for it. Didn't work out that way, but it's a good try. So the way that it works is you first have your source code. Your source code's in a .java file. You compile it using the Java compiler, javac. So if you javac hello world.java, that'll generate a hello world.class file. And the name of the Java file, by the way, has to be the name of the class within it. Everything in Java is inside of a class. And so class hello world. Okay. So there is no concept of a global function. There's no concept of a global variable in Java. Everything, and I mean everything, is inside of a class, and everything uses inheritance. If you don't specify what something inherits from, then it inherits from object. Object is the Java superclass that all classes ultimately derive from. So hello world is a subclass of object. And every function we have in here, if you want to have a global function in Java, a free function, a global function in Java, this is how you do it. It's still part of a class, but it's a static function, so you don't have to say like a.hypot or something like that. You can just say hypot, as long as you're within the class itself. You just say hypot, and it'll work basically like how your regular free functions work in C++. Do you guys see that? Literally everything inside of this file is inside of a class called hello world. We get down to the bottom. No semicolon. You guys see that? There's no semicolon right here. That's the single greatest feature of Java, is that you don't need a semicolon at the end of a class definition. But everything's inside of hello world. And how long ago did the sun die? Everything's inside of a class called hello world, and the file is called hello world. That's not a coincidence. Literally, the file and the class are named exactly the same thing. And when you compile it, you get a hello world.class file that also has the exact same name. And if you have a project, you put them into directories, and the directories are exactly how you hashtag include them, except they don't call it hashtag include. It looks like this instead. Import java.util.scanner. Directory, file. Java, directory. Lang, directory. Math, directory. Everything inside of it. And so in Java, they actually have a directory structure for the include files, and when you include something, you specify the path name to the thing you're going to include. And if you don't specify path name, it'll look in the current directory. And so they use the import keyword instead of hashtag include because it is actually a modern language, unlike C++, which when you hashtag include something, it is going to copy and paste the entire file into here. It is not a good system. The Java way that it imports things is better, and C++ is getting this system finally. I think yesterday, actually, Visual Studio finally did this. So as of yesterday, C++ has what are called modules, and you can import modules instead of doing this really crufty hashtag include copy paste system, which causes all sorts of problems. So Java's include system is actually much better than C++'s. Okay, so and then when you run your program, you can't just run it. You have to run it inside of the virtual machine. That. And, oh, we went out of bounds. Yeah, went bounds checking. Right? So I accessed element 100 out of an array of size 100, which you can't do. So it throws an exception, and it kills it, and it tells you that hello world.java, line 60, you went out of bounds. Okay? So everything in Java is bounds checked and safe. That Java is safe and slow. That's the design of Java, safe and slow. So here's how the process works. You start with your Java file. You compile it into a .class file, and then you run it inside of the Java virtual machine. You say Java my code, and then it will read the class file and run it inside of this virtual machine. The virtual machine will do all the bounds checking and stuff for you. And then the virtual machine emits the actual CPU instructions that run on your local CPU. So as long as yeah, it actually tells you where you went out of bounds. It's really nice. And so as long as you have a Java virtual machine for your system, you can run basically any Java program. There's sometimes version incompatibilities, like if your Java virtual machine is old and you're running a new Java program that's got standard library functions that don't exist, you can't run it. So you will occasionally encounter that, and by occasionally, like I used to encounter it all the time. And so you end up having to sort of write Java for the lowest common denominator. Like if you want to support some system that has kind of only an old JVM for it, then you can't use all the new bells and features like vectors and fancy things like strings and you got to take it back to 97. You know, if you're going to support every Java virtual machine, and so you can't use a lot of the new features. It's kind of annoying. So you kind of have to decide in advance, who am I going to support? I'm going to support Android. You know, most Android apps I would say these days are Java. So you know, if you're going to be doing app development, learning Java is really important. What are pros and cons of using Java versus C++? I've gone over a couple of those. That's a really good question. It's a kind of a big topic. I guess I'll kind of answer that as I go along, if you don't mind. So Java, like I said, is safe and slow. It bounds checks everything. You can't corrupt memory. Can't do a double free because there is no freeing. And C++ defaults to fast and unsafe. But with C++, with address sanitizer and undefined behavior sanitizer and the other sanitizers, thread sanitizer and stuff like that, you can get Java level of safety and slowness. But you can turn them off if you want. So with C++, you have the option for fast. In Java, you kind of don't, right? There's things called JIT compilers that will speed up your Java, but you know, just with some benchmarking I've done on different stuff, you're talking about Java being roughly twice as slow to 10 times as slow, somewhere in there. So yeah, good question. That's sort of the overall philosophy, is that C++ is fast and unsafe, Java is safe and slow. There's some specific things that Java does a lot better, like I said, the importing thing, which C++ is getting now 10, 20, 4 years later. Good job, C++ team. But, I mean, better late than never, I guess. Amazon does a lot of C++ programming. Yeah, sure. I met a C++ programmer at Amazon when I was up there for CPPCon. Sure, they do a lot of C++. You know, if you're into high performance stuff, which Amazon is, you know, there's a lot of C++ on there. Python is a JIT compiler now too. Cool. Yeah, Python also, you know, slower and safer. Honestly, though, if you write modern C++, then so Java was made in a time when everybody had to make their own data structures in C++, and everybody had to have pointers, and you had to call new and delete, and you had to make your own linked list every time, and people would forget one of the pointers, and then your code would explode if you deleted twice in a row out of a linked list or something like that. Java came from those days, the old bad days of C++. The C++ language itself has evolved since then. Modern C++, C++ 11. Like, when you guys took C-Sci 40, you probably didn't encounter any of those super annoying issues, simply because there's things like vectors, and you just stuff things into a vector and call it a day, and if you go out of bounds, it detects it, and, you know, it's modern C++ is really nice to program in, and gives you a lot of the pain points that cause Java to exist don't exist in modern C++. C++ 11. Yeah, those were the dark ages, and it was really annoying. In fact, the worst part of C++ back when I took it were strings. Because the string is an array of characters with a null terminator at the end. And so if you have a string of length 10, you need 11 bytes to hold it. Right? Because you have your 10 characters in the string, and then there has to be an extra byte for the 0 in ASCII, the null byte, at the end of it. And so if you were to concatenate two different strings together, 10 characters and 10 characters, you would think, oh, you need 22 bytes. Nope. You need 20 bytes. Nope. You need 21 bytes. 10 characters from the first one, 10 characters from the second one, one null terminator at the end, 21 bytes. And so people would just make an array of size 100 and just hope that nobody ever needed more than 100 bytes in a string. And when it did, everything would explode and you would get buffer overflows and stuff like that. Because the only other alternative was you would new things constantly. Every time you did anything with a string, you would new the memory, delete the old memory, copy things over, not in that order, or it'll explode. And it was really, really annoying. Now we have the string class, and you don't have to worry about all that stuff. You have the string class. String s equals hello world. It just handles it for you. It's nice. It's really nice. So C++ is kind of caught up to Java in terms of safety and niceness of features and things like that. It's still faster if you know what you're doing. You can, of course, write bad C++ code. That's doable. The Java standard library is arguably a little bit better, I'd say. Yeah, we'll go through it. We'll go through the differences. So here's your most basic hello world in Java. Everything's in a class, and so that includes main. So main is going to be a public. Remember, everything in Java is either public or private or protected, like in C++. But you tag every variable or every function as public or private or whatever, and or default. Static means that it's not attached to a variable of type hello world. It's just attached to the class. It's the same concept in C++, where you can have a function on a, like the enum thing that we're talking about. So you can say class : something. Doesn't return anything. Doesn't return an error code. That's interesting. Name main, and it takes a array of strings. I wish C++ supported this, honestly. I wish C++ had the ability to write main, where you just took an array of strings, or a vector of strings even. Instead, you still get this ugly ass argc argv nonsense, which stems from the C-roll days. This is how you do cout. Rather than cout, you do system.out.println. Println adds a new line to the end of it. If you do print, it doesn't do the new line for you. So here you go, print hello world to the screen. System.out is cout. Okay, it's the same thing. Console out, system.out, same thing. What about end line? The print line, the ln here, the print line adds the end line. If you did system.out print, it would just do a cout without the end line. Good question, Emma. So yeah, so when you ran, if you compile this. In fact, let's do it. Why not? Copy over here. I've already got a hello world, don't I? Okay. Then hello world.java. We need to import. Do we need to import something? Let's find out. Okay. So Javadoc hello world.java. Okay. And then we Java hello world and it prints hello world. So there you go. So that's the development process for Java. You edit a Java file, you compile it, you run it, repeat. Okay. And this is your basic hello world. If I do not do the print line, then it prints hello world. But you see that it doesn't do the new line at the end? Here it did. So. Okay. Is there overloading in Java? Yes. But they don't have operators. We'll get to that. Yeah, so for most things, when you guys learn a new programming language, and that's one of the reasons why I'm doing this, I'm trying to teach you guys philosophically, like how to go about learning a new language. You don't need to learn it from scratch like you did with C++. Instead, you just need to say, okay, what is cout called in Java? Right? Sometimes you'll just Google it. What is a vector in Java? And then somebody will say, it's an array list. Okay, cool, thank you. You know, if the file name is the same name as that class, can you have multiple classes in a file? Nope. You're going to have a lot of Java files. Every class you make is its own file. And that makes it easy for the compiler to find stuff, right? It doesn't have to hunt around when you're trying to use, Bob, class Bob. It's in a file called bob.java. One of the biggest problems with modules in C++ is that they don't have that same mapping between file name and class name and the directory structure, which is all baked into the import system. And so it's kind of up in the air right now how exactly when you import, something in C++, where is it going to find it from? Nobody knows. It's up to the compilers. And so it's sort of a open question right now. Like, how are you going to find stuff in C++? In Java, it's very easy. But it is annoying because you'll end up having 300 Java files in one directory. Right? So the primitive types in Java are byte, not char. Byte is an 8-bit integer. Byte, 8-bit integer. Short, int, long. There are no unsigned integers. C++ has unsigned int, unsigned long, unsigned short. None of that in Java. And again, this boils down to C++ being fast and unsafe. Do you guys know why unsigned integers are faster than signed integers? Do you know what case when it's faster? For bounds checking, actually. For bounds checking. So if you have an array of size 10, the array goes from 0 to 9, right? In Java, you can say, try accessing element -5. And so you have to say, if the index is less than 0 or the index is greater than or equal to 10, die. You need to check for below. You need to check for above. If you have an unsigned integer, if you try accessing element -5, that underflows, it wraps around to positive 4 billion something. And so your check for greater than or equal to 10 will actually pick up checks below. So in C++, you only need a single comparison to do bounds checking because it's using unsigned integers. In Java, you have to have 2. And if statements are actually kind of expensive. If statements, depending on how it goes, they can be the equivalent of 8 or 10 pluses or minuses or things like that. And so by using unsigned integers, size t is a normal unsigned something. Size t is there because some systems are 32-bit systems, some systems are 64-bit systems, right? And so size t on a 32-bit system will be an unsigned 32-bit integer. On a 64-bit system, size t will be an unsigned 64-bit number. And so size t will actually change to match the size of your memory space. But it's unsigned, so that you only need to do one comparison instead of two. You guys feel me on that? Make sense? Do you guys see what? And that's why I actually don't recommend using unsigned for just like normal purposes. Like for the health, of a monster, and every time you hit it, the health goes down. I would not use an unsigned integer there. I'd use an int. So that if you hit it for 10 damage when it's at 5 life, it could go to -5. You could check for that. Whereas if you do that with a unsigned integer, it would wrap around to 4 billion. And so every time you damage them, you'd have to check to see if the damage is greater than its health, and it gets really annoying to do that. So for most purposes, I say just use an int, use a signed integer. But so unsigned integers are really there as an optimization option. They're there so that you only need to do one if statement instead of two when doing comparisons. For normal usage, yeah, just use ints for everything. And then just say if health is less than or equal to 0. It's easy. So in Java, that's the approach they took, because unsigned integers cause so many problems, right? People will set their ammunition to be an unsigned integer, and it'll underflow and wrap around. And in Java, no, there's no unsigned integers. It's int. And if you overflow, I think that's a runtime error, maybe. I don't remember off the top of my head in Java. And so everything's a signed integer. You have 8 bits, 16 bits, 32, 64 bits. And these do not change sizes based on the system you're on. An int is always 32 bits. Whereas in C++, an int is whatever's fastest. So an int could be 16 bits, could be 32 bits. You don't know. There's no guarantee. So Java, again, safe and slow. C++, unsafe and fast. So Gandhi becomes a nuclear warlord. Yeah, it underflowed, right? They used an unsigned char to indicate the hostility of the AI, and it was supposed to range from 1 to 10. And Gandhi was at 1, and I think Montezuma or Shaka were at 10. And when you built the United Nations, it lowered the aggressiveness of all the AI by 2. And so Gandhi went from having an aggressiveness of 1 to an aggressiveness of -1, which if they were using a signed integer would have been fine. But they weren't. They were using an unsigned integer, so it underflowed. Gandhi went up to being 25 times more aggressive than the maximum aggressiveness in the game. And he immediately starts building nuclear weapons and bathes the world in nuclear fire. So one of the more amusing bugs of all time. Floats are always 32 bits, doubles are always 64 bits. You have a Boolean, capital B Boolean class. Chars are 16 bits because they do wide characters by default, Unicode by default, kind of. String is capital S, not lowercase. You can make an uninitialized variable, but if you use it, it's a compiler error. The compiler knows if you try doing anything with uninitialized variables. We talked last time about this. You have the box type. So in addition to int, you have integer. In addition to float, you have capital F float, right? And these guys can convert to and from the primitive types automatically, basically. Integer Bob equals 7, just fine. And the nice thing about having a class, though, is that classes, these things don't have member functions, right? They're primitives. They're not classes. You can't call int.toString, right? Because it's an int. It doesn't have any member functions on it. It's a primitive. But the integer class, sure, bob.toString, and it'll convert 7 to 7. Right? So I typically probably use the capital letter box classes more than the primitives. I don't know. Consts are public static final because, why be concise in Java? Java is verbose. Okay. We talked about this last time. You have anything that's not a primitive has to be nude. And the reason for this is because in Java, only primitive types can be passed by value. Everything else in Java has to be passed by reference. And so there's a pretty stark division in Java. You have your primitive types, which are these guys here up top, And then you've got everything else. Everything that's a class type, everything gets newed. And when you pass a variable of a class type to a function, it is always passed by reference. It doesn't look like it's passed by reference, but it's passed by reference. So if you... do I have an example here? Let's go back into here. So if I wanted to pass void to take in a hello world that, let's see if I can do this through this. Non-static variable cannot be referenced from a static context. Yes. Right. This is a static. It's not actually attached to a class. Yeah, anyhow, the point I'm trying to make here is that it doesn't look like you're passing this by reference, right? It looks like you're passing it by value. Nah. In Java, everything is passed by, it looks like this. Everything looks like it's passed by value, but it's not. If it's a primitive, if it's an int, it's passed by value. It makes a copy. If it's a class type, if it's an object, it is passed by reference. That's the rule. And that's why when I'm teaching C++, I actually teach you guys to kind of follow this rule. Like, by default, anytime you pass an object, anything you pass anything of class type to a function, by default, you should pass it by reference. Either const reference or non-const if you're going to be modifying it. So yeah, if you pass a string to a function and you change the string in the function, it changes back in the original context. Everything is passed by reference. That's the rule. Primitives are passed by value. Everything else is passed by reference, but it doesn't have the ampersand. It's just everything just is a parameter. So so kind of in Java, there's no pointers also. Like you don't pass pointers to things. But the reason why it works is because everything's a reference. And you can actually set references to null in Java. So if you want to do a linked list, you just set my next value to null, and it works. So you don't have to have header files. The language figures out where everything is, which is nice. You don't have to forward declare things before you use them. The compiler goes through the whole thing and figures out where everything is. I kind of wish C++ would just do that these days. It's kind of annoying to put a function declaration up top and then have to do a definition down below. And if you edit the function, you have to go up top and edit that one too. In Java, you only have to do it in one place, which is nice. It's nice, for sure. Okay. Yeah. Yeah, there's no globals in Java. Everything is inside of a class. Everything's a member function, or everything's a member variable. Okay. So, no operator overloading. This is a big thing. So the Java people looked at operator overloading, you know, like when you do cout double left arrow, and the double left arrow is the bit shift operator. The Java people just looked at it and went, nope. Nope, not doing that. No operator, square bracket, no operator star, no operator anything. There is no operator overloading in Java, with one very small exception. Strings, you can plus strings together. So if you have string A and string B, you can say A plus B, and it will concatenate the strings together like in C++. Or actually probably C++ copied that from Java, but either way. That is the only example of operator overloading in the entire language. They special cased it because everybody wanted to add strings together. So you can add strings, but literally, that's it. All the operators in C++ are in Java, and that's deliberate. Like you can actually take C++ code, like you can take C++ code and just dump it into Java, and look at the compiler errors. Like, oh, there's nothing called cout. Oh. Change cout to system.out.println. Make it a function. You can literally port from C++ to Java pretty easily. It's not automatic, but like all of the operators in C++, double equals, not equals, bitwise operators, bitwise and, bitwise or, bitwise not, XOR, which I don't know if we went over or not. Logical not, assignment, plus equals, left shift, right shift. Every operator in C++ works exactly the same way in Java. Okay. There is actually a triple right shift operator, which is used. There's a difference between what's called logical and arithmetic shifting operations that you'll learn in 45. It doesn't really matter for right now. Yeah, order of operations, exactly the same as C++. Everything ends in a semicolon, just like C++. If statements and else's and for loops, just like C++. If statements are the same as C++, if else is the same as C++, switch statements are the same as C++, while and do while is the same, for loops are the same, range-based for loops are the same, break and continue are the same, return statements are the same. Yeah, if you know how to program C++, you can just sort of, yeah. Do you guys see why I'm like, yeah, I can teach this in a week? You know, it's like the nuts and bolts of the language are basically the same, right? Like, if I come over here and, you know, said int x equals 10, if x is less than or equal to 10, system.out.println, yo, yo, yo. Right, you guys could read this, right? It's not going to blow your minds, right? What's your personal opinion on that? No operation overloads. I actually like operator overloading, but I know why the Java people did it. You know, I kind of get it, because there is a tendency in the C++ community to make operator overloads that really shouldn't be operators. You know, I've seen people use plus to insert things into a database and minus to delete things out of a database, and so you're looking at this code and you're like, we're doing adds and subtracts. No, those things are actually generating MySQL calls that are manipulating databases, and you're just like, what the hell is going on here? Because, you know, plus to me is like you're adding, you know. But yeah, people really abused the operator overloading system, and so the Java people are just like, nah. If you want to do an insert into a database, call insert. If you want to do a delete, call a delete. You know. Job security, yeah. Yeah, but you guys got this, right? Pretty easy to read, code on screen. Yeah, it's like there are differences. Obviously, this is a little bit different here, and you know that's not C out, but it's pretty close. Yeah, it's pretty close. And so you can learn Java, like the nuts and bolts of the language, the ifs and the else ifs, and else. If x is less than 20, you might notice it's a lot more typing in Java. Everything's a lot more typing. System.out.println. Right? Instead of cout. All right. That's Java. Java in a nutshell is just super, super verbose. All right. So. Any other changes in syntax, like how cout changes the system.out.println? Yeah, there is. So we'll go over that. But the core language is exactly the same. You got your curly braces, you got your semicolons, you got your for loops, you got your while loops, you got your, yeah. The core language is exactly the same. What's going to change is the standard library. So cout is not part of the C++ language, right? Cout is part of the standard library, which comes with every compiler distribution, but it's actually not in the language itself. So the core language itself is actually pretty similar. It's pretty similar. What are switch statements? Don't worry about it. It's like you'd say switch x case 10. Yeah. It's a kind of garbage way of doing if, else if statements. Some people like them. I hate them with a burning passion because of the number of bugs that I've seen it create. It breaks your standard curly brace way of doing coding in C++, so I don't teach it. but it's basically an alternative to if, else if, else if, else if, that in some cases might be faster, but only does double equals comparisons. You can't do less than or equal comparisons. Only works with, it doesn't even work with strings, you know, and things like that. So yeah, I don't like it. Okay, so yeah, so every time you have a object, it has to be nude. You always new things in Java, always. The only things that don't get nude are the primitives, and there is no delete. So you just new things and let the language itself handle when they should be deleted. Constructors are the same as C++. You make a member function with the same name as the class, you know. So I can make a constructor. Yeah, same thing. The way that privacy works is a little different. I've already kind of talked about this a little bit. So in C++, we have public sections. You say public colon, private colon, protected colon, and then everything in that section has that privacy. In Java, each individual member function or member variable is tagged as either public, private, protected, or default. Inheritance, rather than colon, public, parent, like we did inheritance, right, last time, you say extends. So jobs bitfield extends bitfield. That's how you do that. And every class extends another class. If you don't specify anything, it extends object, which is the Java superclass. Okay. So in Java, you just have to remember to put a public in front of every variable you want to be a public variable, or private in front of every variable you want to be a private variable, and so on and so forth. So in Java, there's public, private, and protected, and then there's default. Okay. Default is private, except there's this concept of packages, so you can package up a bunch of classes together, and everybody in your package could access your private member variables. So if you don't give any access specifier, it's private, but everybody within your package has access to it, which is actually a pretty decent default, right? Because if you're writing code, then you know what's in your code, and you don't have to worry about your client code modifying your private member variables, but your stuff, because you're going to be spitting out classes left and right, and so all the classes in the package can read and write to each other's member variables without needing to go through an interface and all this kind of stuff. But when you ship this code to other people, they have to go through your public interface. So they have to call your public member functions, and they can only access public member variables, but all of your code can talk to each other without going through these things. Even still, I would still probably use private. Depends, I guess. So, yeah. Public works the same way, private works the same way, protected works the same way. There's no arrow operator in Java because there's no pointers, right? So in Java, there's no pointers. And so if you knew something, like if you say hello world there, integer I is equal to new integer. You don't say like I points to string or something like that, right? Nah, that's nonsensical. There's no arrow operator. There's no arrow operator in Java because there's no pointers. Everything's a pointer, but yeah, pointers are scary. They're not pointers. They are pointers, but they're not pointers. So everything in Java is just that. So everything in Java uses dot. Okay? So there is no pointer types in Java. Even though they're all pointers behind the scenes, there's no pointer type, there's no stars, there's no referencing and dereferencing variables, none of that stuff. Just everything looks like a regular variable, and you use dot for everything. I kind of like it. You don't have to think about if it's an arrow or a dot. It's just always a dot. Okay. For April Fool's this year, the C++ committee released a paper saying that they were going to allow dot for everything instead of arrow or dot, right? arrow is used with pointer types, dot is used with regular variables. And so they released a paper saying they would just allow you to use dot with pointers. And I was excited. I'm like, sweet, this will be like, Java. You don't have to, if you convert a reference into a pointer for some reason, you have to go through and change all of your code that uses it. And so you'll have like dot this, points to this, dot this, and it looks really weird. So I was excited. Like, it would actually make refactoring code a little bit easier. But it was an April Fool's joke. So it's like, damn it, guys. Got me excited for nothing. Just like, China Peak got me. Man, a couple years ago, they released an April Fool's joke saying they were going to build a chairlift to Mammoth. Because Mammoth is just over the mountains, right, from China Peak. It's not too far. As the crow flies. So there's Mammoth, right there, right? It's actually not that far away, right? Mono Hot Springs is here. I don't know if you guys have ever been to Mono Hot Springs. It's nice. That road's killer though. But I went hiking Tule Lake. Yeah, so I hiked from Mono Hot Springs up to Tule Lake. Went swimming around in the Alpine Lakes up there, and Vermilion Resort is a backpacking resort town. Yeah, anyhow, so you can go from China Peak to Mammoth, like, I don't know, it's 20 miles or something like that. It's really not that far. And so when they announced they were going to build a chairlift and allow people from China Peak to ski at Mammoth, which is one of the best mountains in the world, I was like so psyched. And it's like, April Fools. Seriously, guys. Like, they had blueprints and like all this stuff. Man. Shame. Yeah, so I do like that. So you just use the dot operator with clap. Like, everything is the dot operator. It's easy. Yeah, so you can say this dot something. So there's no pointers in Java, even though they're all actually pointers. Under the hood, they're pointers. But pointers are scary, so they don't have pointers. Okay. All Java classes derive from object. So capital O object is the superclass that everything extends from. If you don't extend from something, you extend object. And if you don't extend object, then you extend from somebody that extends from object, ultimately. So what's nice about this is that every class in Java has the following things. All of them have a hash function. Everything, because hash tables are important, right? And I think you guys can understand why, after taking this class, why it's really important that every object has a hash function, right? Because hash tables are really, really cool, and they're really fast. And so if you're going to make a hash class of some sort, they have templates in Java. You can make a hash table of templated type, of any type T, and then you know that you can just call that, whatever's passed in, you can call its dot hash code, and it'll hash itself. So for an integer, it might just be its own value. For a string, it might add the letters together and do some, black magic to give you a hash code. So in Java, every variable that's not a primitive has the ability to hash themselves automatically built into them. It's really nice. It's really nice. In C++, you have to overload the std hash function. Doing so is a little bit weird. So a lot of people don't do it for their classes they make. Like, how many times have you seen me do it? Once this semester? Twice? I don't know. Not that often. In Java, everything overloads it, right? So toString converts an object to a string. Now, of course, if you don't overload it, then it probably, won't do anything interesting, right? But at least you can call hash code on every variable, and it exists. toString will convert any object to a string. This is useful for what's called serialization. If you're going to dump a class to disk, like you're going to save, your game or whatever, You can just say, for every hero in the world, for the range base for loop, for every hero in the world, call hero.toString, and then write that string to disk. So maybe the first line you write is how many heroes there are. There's 10 heroes. And then you have 10 paragraphs. Each paragraph holds all of the information that the hero has. And because everybody has a toString, when you're writing the hero class, the hero serialize can call the toString on its member functions, its member variables, and it can serialize basically everything. Clone is the copy constructor, basically. So they don't have copy constructors exactly. Instead, if you want to duplicate something, you call clone, and that makes a duplicate of it. And equals, so this is kind of like a copy constructor. This is kind of like the double equals operator. So if you want to see if one object equals another object, you call the dot equals. Because again, they don't have operator double equals. They don't have operator less than. And so they have like compare to, equals, clone, things like that. Because they don't do operator overloading, right? They don't do operator overloading, so they have named equivalents, equals, compare to, clone. Okay. All right, so C++ can kind of do interfaces. Like when I made that hash class, the pure virtual hash class that had nothing in it, that's equivalent to a Java interface. So an interface is just saying, here's some member functions, and anybody who implements this interface will have those functions on you. And so the two subclasses of the hash table class had all those functions implemented. And so that's kind of how you would do it in C++, using abstract classes, pure virtual abstract classes, like we did with the hash assignment. So in Java, though, you can just make something called an interface, and an interface just says, here's these functions. Anybody who implements this interface must implement these functions. It's a little bit cleaner. It doesn't use inheritance, right? It's not inheritance. It's just they have these functions, which makes things a little bit cleaner. So for example, comparable, if you implement comparable, that means you have the less than operator. Okay. And so what this allows you to do, and C++ is finally getting something similar to this in C++ 20, which is called concepts. But what you can do in Java is say, I'm going to write a sort function, and the sort function will only take comparables. So any class that implements the comparable interface, any class that has a compare to function on it, I can sort. I know how to deal with it. If I'm going to make a binary search tree class, I will make a binary search tree class of comparables. And so the only people that you can put into a binary search tree class are types that implement compare to, that implement the comparison operator. Compare to is operator less than, essentially. And so this is really nice. So if you make your own class of like Bob's, and you try putting Bob into a binary search tree, the language itself will say Bob isn't comparable. It did not implement the comparable interface. Reject. Right? There you go. I didn't know I had to. And so you go up into the definition of Bob and you say Bob extends Steve implements comparable. And then you add a compare to function on it. Now it will go into the binary search tree class. It's really nice. And in C++, what happens is you have a templated binary search tree. Somewhere within there, the binary search tree has the less than operator, right? And if the less than operator isn't implemented on Bob, it tries doing all sorts of different conversions, trying to find a comparison operation that works. None of them works because Bob hasn't made an operator less than. And then you get 900 lines of error messages in C++ saying template substitution error, template substitution error, template substitution error. I tried converting Bob to a string, but I couldn't. So I'm going to tell you I tried it and it failed. Now I'm going to tell you that I tried converting Bob to an integer, but I couldn't and it failed. Here's 20 lines of error messages about this thing that nobody in the right mind would ever do, but I'm going to tell you about it and it didn't work. And so C++ will blah and give you 900 lines of error messages None of which matter, because you never want to convert a Bob to a linked list. Like nothing that has any relationship to anything. It's just finding everything that's got a less than operator on it, and it's going to try converting Bob to that, because then that would allow Bob to compare. And it just is like, here you go. Here's all this useless information that nobody gives a damn about. And then you have to scroll up to the very top of those 900 lines of messages and be like, oh, operator less than is not defined. Cool. Thank you. Java, it's a lot cleaner. Interfaces are like subclasses. Not exactly. Interfaces are like a superclass. Like, if you guys... So if you guys remember this is basically an interface. So it's a superclass. In C++, we do it using inheritance. In Java, it's not inheritance. In Java, when you make an interface, you just say, here are 4 functions you must implement. And so when you write a class, rather than inheriting from it, like you do in C++, in Java, you say linear probing hash implements hash. And then you have to make sure you write the 4 functions: insert, remove, search, and change. So it's not inheritance. It's not a subclass of hash. And that's important because in Java, they don't do multiple. There's no multiple inheritance in Java. Java does not do multiple inheritance. You can only inherit from one thing. But you can implement as many interfaces as you want. So if you want your thing to implement comparable and hash, that's fine. You can implement as many interfaces as you want. You can only inherit from one class to stop that diamond inheritance problem. But this is how we would do it in C++. In C++, you just make a bunch of virtual functions and set them equal to 0, which means they don't exist. And so if you try making a variable of type hash, if I tried saying hash h, then the compiler will yell at me. Sorry, can't make it. But these guys that inherit from it, which actually implement these functions, they're fine. And so in C++, we make a variable of type hash, which is the superclass, the interface. And then we can set that pointer to be equal to either a new linear probing hash or a new chaining hash to do the magic of inheritance. So a pointer to a superclass can point to any subclass. And it works if it's a pointer. If it's a normal variable, it doesn't work. So like I said, when you do inheritance, you oftentimes are forced into using pointers so that you don't slice the variable. And so, and that's one of the annoying things about inheritance that I don't like, because it oftentimes sort of pushes you in the direction of using pointers when I prefer to not use pointers. And so when you call table.change here, if your mode is linear, then it's going to call the linear probing hashes change. And if it's not, then it's going to call the chaining hashes change. And so down here, I don't have to have any if statements or anything, right? Because the table interface has change, insert, search, and remove. And so I just call search and insert and remove. I don't have to have any more if statements, right? Because I've got an interface, and then I pick which class implements that interface. And it works really nicely. It works nicely. Okay, so yeah, and so basically anything involving a binary search tree or sort will require your class to implement comparable. And then if you don't, it gives you a nice error message instead of 900 lines of error messages. It'll just say, hey, you're not implementing comparable, dude. Sorry. Can't work with you. This function requires comparable. You're not comparable. Don't know what to tell you. Sorry. Can't get in. So this is a, and see how it doesn't have any function body or anything like that. The interface just says anybody who implements this interface must have a public int function named compare2 that takes another object. Okay. That's usually how you do it. Data structures in Java, like I said, references in Java can actually be null. They can't be null in C++ unless you do something horrible. So here's a linked list class. Got a head of the linked list, which is going to default to a node with null pointer. And if you're going to add something to the linked list, then we new a new node. We set the current to be equal to the head. We go down, what was that, going to the bottom. So while get next is not null, current equals current points to next, essentially. So this is going to iterate down the linked list. And then it's going to set the next on the node to be the new node. So you can see how, like, even though these things are variables, they're not pointers, they can still be tested to see if they're null. And so they're pointers. You just don't have the star, because the star was scary for people. Basically, the code works exactly the same way as in C++. While current points to next is not null, current equals current points to next. That's the same code in C++ and in Java. Generic programming works the same way. Angle bracket T. Works fine. So my class, angle bracket string, yeah, works exactly the same way, except the syntax is a little different. You don't have to say template angle bracket class T angle bracket. You just do this. And it's now a templated function. Easy. Or templated class. Easy. Yeah, so basically templates work the same way. Data structures work the same way. The syntax is a little different because there's no arrow, right? There's no arrow, everything's a dot. But basically, it takes like, I don't know, a few minutes of work to convert a C++ data structure into a Java data structure. You're still newing stuff. You're still checking for null. It's called null instead of null pointer. So there's a couple fiddly things you have to mess with. But honestly, I've ported a lot of code from C++ to Java, and it's really not that hard. It's really not that hard. The only bits that you actually have to swap out are the standard library functions. So like if you're going to be using a vector in C++, you have to go onto Google and be like, what is a vector in Java? You're like, oh, it's an array list. Okay. Switch it over, and there's a couple things like that. It's not trivial. Like it's not automatic, but like I said, I've ported a lot of stuff to Java, and it's really not that bad. You know, it's really not that bad. Like you can learn Java, you know, really kind of easily. Generic, yeah, like just copy paste, delete the template class T. Okay, get rid of that. You know, there's no private and public sections. You have to kind of put those in there, and it takes a little bit of time. It's not it's not that bad, honestly. So if you're pretty good at C++, you will be able to use Java. Yeah, you gotta really sit down and just spend like a day or two, you know, kind of getting acquainted, getting oriented, and then yeah, you're fine. If you look through my search history at the time, it was all like, how do I get the time in Java, you know? And yeah. How do I make a hash table? Right. And so you just click on it and like, all right, okay, here's some source code. Yeah. Oh no, these are actually making one, huh? Oh no, here you go, hash table. So yeah, and so basically, if you looked at my browser history at the time, it was all just like, how do I do this thing in C++ in Java? And the names are, you know, it's not an unordered map, it's a hash map or whatever, you know. Are there existing containers in the Java standard library? Yes. Yeah, they got different names though. They got different names. But yeah, all the standard containers are in Java. Okay. Yeah, and so you just like, what's the name of this in Java? And you just kind of translate. It's really not a big deal. Because the important thing from this class, right, is learning what data structures are good at what operations, right? When do you use a linked list? Almost never. Sorry. When do you use a vector, right? When do you use a hash table? When do you use a binary search tree? I feel like C++ is the base language and the rest are branches. Yeah, C Sharp's the same way. C Sharp is a derivative of C++, more or less. It's like Java, except Microsoft owns it. Right. And so it has a lot of the same features of Java. It does bounds checking and stuff like that for you. It's different, but I mean, C Sharp's nice. I like C Sharp, I like Java. It's not, if you know C++, you can learn them, like, yeah, it's not instantaneous, but it's not bad. It's not horrible. It's not that time consuming. This is something about Java I really like. It's called Javadoc. So I used to have a dog named Java, by the way. All of my family's dogs are named after programming languages, and this was prior to me like becoming a programmer. By the way, my family, I guess, is just nerdy. I don't know. We've got Pascal and Java, and so this is Javadoc. Javadog, I'd call him Javadoc. And do you see how there's this extra star here on the comment? That means this is documentation. And so you can add a comment with that extra star there. And then when you run Javadoc on your code, it'll actually make documentation for your project, which is really nice because programmers hate doing documentation. You've probably seen the result of this before. C++ has something called Doxygen, which kind of does something similar. No, wrong bridges. Why does UNCC have 2 bridges? Why does it have 2 bridges? Bridges Scholars. No, thank you. Bridges main page. Like Java API. All right. So if we go to the list of classes and let's look at the circular doubly list element. So you see how there's like hyperlinks that are nice, and it has a thing like this, a description, and description of the parameters. This might have been actually done using Doxygen. Yeah, this is a Doxygen thing. It's kind of noticeable. But Javadoc does something very similar to this, where it will generate. These are the 4 different constructors available, and you just have your comments above every function like this, and it will pull those comments out and put a description, and it'll have the function there and the parameters and a description of it, and it's really nice. It just generates documentation for you. So if you're at a program that runs 24/7, what I do is I have a shell script that just says while true, run the program, and then when the program quits, it just runs it again. So if your program is going to crash occasionally, which like the Quake server would crash every couple days or so, it would just reboot it. Yeah, and so this is a really neat thing. You can tag things as deprecated. C++ has added this, by the way. You can do square bracket on both sides deprecated. So in C++, you can do something like that, and then it'll give you a warning. Warning: using table is deprecated. It doesn't kill your program or anything, but you can just tag things like you shouldn't use this. So you can tag a function as like deprecated. Deprecated means don't use it anymore. We've got a better alternative. Don't use hash table. We've got hash table 2. And so what you can do is you can tag hash table 1, your old one, as deprecated. And when you push out the new version of your library, people that are using the old code are going to get a compiler warning. And so, and you can put a note in there like deprecated. Hey, you should upgrade to hash table 2. It's better in every possible way. And so it's like a way of sending a message to the people who are using your code. Hey, don't use this anymore. Use this one. It's better. And so C++ does it with the square bracket deprecated. There's also like no discard, you can put that onto a function, no discard, and then that will warn if you do something. It's like, let's say you call system to do figlet. Set. Yeah. So if we make this warning, ignoring the return value of system. So system is declared as no discard. And so system has the square bracket, no discard on it, which means you cannot ignore the error message, please. It'll still compile. Like you saw that, it's still compiled. But it sends you a warning if you don't use the return value of a function. And to me, this is actually really annoying because I actually don't care about the return value of system. System does something, and then it just returns if it was successful or not. And frankly, I don't care. I don't care if it was successful or not. If figlet fails, not a big deal, right? So to me, that's actually a really annoying thing. They made system no discard. But if you had a function like square root, like if you're making a square root function, you know, int square root that takes x, return x divided by 2. It's a square root function that works for exactly one number. No, it works for 0 and it works for 4. It works for 2 numbers. So for this function, if I'm not capturing the return value on it, I'm doing something wrong. You know what I mean? Like if I'm down here and I say like int Bob is equal to square root of, it's not called the square, let's call it Kearney squared. Right. So if I'm not capturing the return value of this function, like there's something wrong. You know what I mean? Like this function is absolutely pointless right now because all it does is return a value and I'm not doing anything with the value. Right. So this is the kind of function that should be tagged as no discard. Right. And then now it's a warning. Warning, you're ignoring the return value of something tagged as no discard. Right. So this is actually, anytime you have a function that it's literally pointless. It's literally pointless to call this function if you don't do anything with return value. Tag it as no discard. Right. System though irks me because it does something. System will print hi to the screen. So it bothers me that system warns if you don't do anything with the return code. Because honestly, I don't care if it succeeded or not. Cool. Oh, Figlet's not installed? I don't care. It's fine. It's okay. So, access hash table and updates values based on user activity. Breaks by giving the wrong key, new value errors. Does this sound like a memory leak? I don't know. Maybe. So in Java, we do that not with the square brackets, but with at deprecated. And if you want, if you're like, no, I want to use the old system. Like, let's say you want to benchmark hash table versus hash table 2. And you don't want to be yelled at every time you do the old one. You're like, no, I just want to, I'm going to compare them, you know. Then you can turn off the warning on it. And you can do this in C++ too. So if you want to turn off a deprecated warning, you can do that. You can turn off a no discard warning. Like, I know, I'm benchmarking it. I'm not actually going to use the return value from Kearney square root. I don't care about it. Go away. So you can turn these things off too. But in Java, it's done using the at character. In C++, it's square bracket, square bracket. So you guys learned some C++ today too, maybe. I don't know. We don't use hashtag include in Java. We use import. So if you want to import the Gregorian calendar or the Julian calendar, you can do so using that. And so you can make a calendar with a year, month, day. This is an enum. And so Java's got a pretty good standard library. I kind of like it. It's pretty good. You know, in a lot of ways, it works better than the C++ standard library. Because the C++ standard library design has been sort of nonsensical to me. Because to me, a standard library should be good at doing common tasks, right? And the C++ people have been like, nah, we're going to make it complicated to do a common task. You want to make a random number from 1 to 10? Nah, you have to memorize MTT 19937 something. You know, good luck, first semester computer science people. Screw you. You know, like, to me, it's just like, just give me the ability to make a number from 1 to 10. That's all I care about. Just give me a number from, like, just give me a number. Like, I don't need all this other stuff. And so Java and Python have, in some ways, a much easier to use standard libraries, but C++ has got the Bessel function of the first kind. So I don't know. I don't know who wins there. Bessel function of the first kind or Java that can do networking. Because Java has networking in standard libraries. C++ doesn't. C++ uses the C libraries for networking, and they were written prior to the internet being a thing. So maybe that should be done before adding Bessel functions of the first kind. I don't know, guys. Come on. It's just a bizarre process that, because there's like these filtering processes, and it's just like what gets people excited on these committees. And apparently Bessel functions of the first kind get people excited. Sure, let's do that. You know, whereas things like, you know, making I/O sane and making socket, you know, networking programming easy and easy random numbers. These don't get people's, you know, excited for it, so they just die. Yeah. I've taught networking before in CSI 45. I'm going to teach it in this class. So that'll be your final assignment, actually. Networking in Java. Because networking in Java is actually easier than in C++. Because C++ doesn't even have the concept of like a keyboard and a mouse, right? I guess keyboard input works, but like Windows and like mice and audio and networking, none of these things exist in the standard library, just the keyboard. So if you want to make a PowerPoint in C++ using just the standard libraries, you can't. In Java, you can. The Java standard libraries have the ability to create a window and put buttons on it and make it so that when you click a button, it calls this function. It's the same. Okay, so here is a summary of the changes between Java and C++. You don't actually make an executable out of it. You make a intermediate thing that the Java interpreter will read and then run on its own. Instead of consts, use public static final. Bytes instead of chars. There's no pointers. Technically, they're all pointers. They're all references. You know, however you want to put it. There's no operator overloading, so you don't have a less than operator. You have compare to instead. Use import instead of hashtag include. Everybody derives from object, which gives you some functions on every class, which is nice. Being able to hash. The compiler documentation and hinting system is nice. And then you only have to new things, you don't have to delete them. So that's Java. In fact, that's pretty much all you need to know to do Java. I could push out a easy homework assignment to you guys if you want. If you want to take a crack at it. So this is a CSI 40 assignment. And so if you guys want to just poke around with Java and try and do it, I guess I can let that make up for any of your missing individual homework assignments. Does that sound good to you guys? So if you got a 0 on any of your individual homework assignments, do Java rainfall. It'll substitute in for your grade. I don't want you guys failing. I want you guys learning. Okay. And so that's it's a CSI 40 assignment. It's just in Java. So yeah. So that'll be a little easy snack kind of thing. When should that be due? Guess I'll make that due on Monday. That way it won't conflict with the Huffman coding assignment. Okay. Full 10 points, sure. Yeah, why not? Yeah, I'll give you the weekend for it. Start looking at it now. If there's any questions you have about Java Rainfall, I'll come to class on Friday with them, and I can go over any questions you have on it. And then after you guys do Huff encoding, remember the hash table competence exam just went live. It's not hard if you understand hash tables. You'll do fine on it. So that's due on Monday also. The hash table competence exam is due on Monday. That's 20 minutes of your life. It's not bad. And then Java Rainfall will do on Monday. Huffman coding will do on Wednesday. And then after that, I'll give you guys like a networking assignment in Java. And that'll be due during finals week. And all the competence exams, I'm going to be periodically releasing more retakes on the competence exams. And those should all be wrapped up by the Friday of finals week. And that'll be it for the semester. So, Rainfall due this coming Monday. Yeah, the coming Monday. It's like I don't know. Enter daily rainfall data, 10, 20, 30. Negative 1 to quit. Average daily rainfall is 20. Count of days that had rain, 3. Maximum rainfall, 30. Top 5 days of rain, 10, 20, and 30. That's it. So you're going to put things into a data structure, and you're going to do a little bit of averaging. That's it. Top 5 days of rain, so you're going to sort it and then print out the top 5. Some days might not be rainy, so 10, 0, 20, 0, 30. So some days had no rain. So the average daily rainfall is 12, because there were 10 plus 20 plus 30 divided by 5. 60 divided by 5 is 12. The average rainfall on rainy days is 20. 10, 20, and 30. Average together is 20. How many days had rain? 3 out of the 5. Max rainfall, 30. Top 5 days, 30, 20, 10. So it's not, like I said, this is a CSI 40 assignment. It's just in Java. This is not bad. Word count, long, Java. Let's see. So 81 lines of code for me. So. A little bit of boilerplate, 8 lines of boilerplate. Array list is the vector thing. Collections has the sort function in it. So basically to do this, you're going to be like Googling like, how do I read an integer in Java? How do I insert into a vector in Java? Or I can go over some of that on Friday if you like to. Okay. Did your CSI 40 class used to be in Java? No, same as this. So I taught him C++ and we finished a couple weeks early. So I'm like, all right, we'll do Java. It was last spring. It was the last time I did this with him. And so whenever I finish a semester early, then we do Java, because if you transfer to another university, they're going to expect you to know Java, at least a little bit. Pretty much most universities teach Java, C++, or Python in some combination. Okay. So that's it. Don't do like one of my students who went on to rate my professor, be like, Kearney told us to Google stuff. What am I paying his tuition for? It's like, I can go over the stuff with you guys, but literally that's like, if you're a C++ programmer, that's all it takes to do Java, right? Like, I've got this thing in C++, I want to know how to do it in Java. You just Google it and like, oh, it's called that, and then you just do it. I'm trying to teach you guys that. Like, that's how real programmers work, right? We just look stuff up and do it, right? So, but if you have any questions, I'm always here. I'm on Discord. I will lecture more on it on Friday, I guess, if you guys need it. But just kind of get into that mindset of like learning how to acquire information and put it together and solve puzzles and things like that. If you have more time, can you introduce Python? Sure. We did that, I think, last semester. Did we, Amelia? I read my own, rate my professor reviews. Yeah, not that often. Like once or twice a year. Just because, I don't know. It's like, what are they saying about me? I don't know. Data analysis in 26. We use Python in that, yeah. Mm-hmm. All right, that's it, guys. Thanks for coming out. And so get cracking on this. And again, if you need a partner for Huffman coding, get a partner for Huffman coding. You don't have to, but I would. So post on the Help Center, post on here, get a partner. Okay, that's it. Peace out, you guys.